Welcome to today's video where we will be discussing strategies for eliminating answers on the GRE Math Subject Test. Today's problem comes from a practice test and it states the following. The intersection of the planes in R3 given by x plus 3y minus 2z is 7 and 2x plus y minus 3z is 0 is which of the following? We have 5 possible answers listed right here. Okay, so in order to answer this question, a fundamental thing is to understand geometrically what's going on. We could, if we wanted to, solve the system of equations given by these two equations to figure out an answer, but our goal here is to figure out ways to solve these problems quickly on the GRE Math Subject Test, and one way is to analyze what's going on geometrically. So to do that, we'll first write down the coefficient vectors for these two planes. And in this case, the coefficient vectors are the vectors 1, 3, negative 2, and 2, 1, negative 3. Now, why are these helpful? Because as a consequence, notice these two vectors are not parallel. And so these two planes must intersect. The intersection of these two planes is going to be some line, because these two planes are not the same plane. And so just from the geometric information encapsulated by the coefficient vectors, we can eliminate a whole bunch of answer choices. Answer number 1, or answer A, says that the intersection is empty, B says it's a point, and C says it's a plane, whereas we know now that it's a line. And so 3 answers are eliminated off the bat. And now the question is how to distinguish what the answer is from the 2 remaining choices that we have. All right, so another piece of information we know geometrically about the coefficient vectors is that these vectors are actually perpendicular to the planes given. So we'll actually draw this in. So one of the planes has one of the vectors perpendicular to it, and the other plane has its coefficient vector perpendicular to it. So now we have this diagram where we have these two planes and we have these two vectors that we know are perpendicular both. So then notice that the line of intersection, this dotted line, is a line that's perpendicular to both these vectors drawn in here, u and v. Right? If we take a look at our answer choices, we can determine the direction of the line in both cases by looking at the coefficients beside the t's. Right? And in these two cases, we can write down what the coefficients beside the t's are. In the first case, the coefficients are 1, 3, negative 2, and the second case, 7, 1, 5. Okay, and a quick check with the vector 1, 3, negative 2 shows that it's not perpendicular, for example, to the vector here. If you take the dot product of these two, you get something that's non-zero. As a consequence, it must be the case that this vector is perpendicular to both of these because it's the only answer choice left. And so our answer is choice D. Right? So it seems like, given this problem, a straightforward way to solve it is to actually solve the given system and find the equation of the line. Right? But eliminating answer choices by understanding the geometry in this particular case allows us to restrict the number of correct answers possible and gives us a much better chance of quickly solving this problem. Thank you for watching today's video. If you liked the video, please click the like button below. And if you're interested in seeing more videos of this type, please subscribe to the channel.